All right, guys, we are going to do reduced row echelon form today, which is fancy dancy. But it's all going to be done on the calculator. But so you're going to need your graphing calculator handy. But before that, I want to show you how to do this by hand, just so you can see how much the calculator is saving us and why this really works. So I don't want you to try to write all this down. I just want you to watch for just a couple minutes. So back in Algebra 2, when you had a question like this, it was a long, drawn-out process. You would pick two of the equations and get rid of one of the variables. So you would add these two, and the y's would drop out. Okay, so the y's dropped out. But then you had to pick another set of two so that the same variable would drop out. So for example, I could write this equation down here, and then I could maybe take this second one and multiply it through by a 2. And add it, because I want the y's to drop out again. Now, we happen to be in luck because this equation and this equation up here both have a 5x. So if I multiply this one through by a -1 and rewrite it underneath this one, I can add these and solve for z. Then I can plug that back in somewhere. Add 2 over here. X is -1. And then I can go back to the original equations up here. And it said x minus 2. Whoop. I'm trying to find y now, sorry. If I go back to the original equations, up here, I could pick maybe this second one and write 2x plus y minus 3z equals -7, and then I can solve for y. So to get rid of this, I'd need to add 2 to both sides. To get rid of this, I'd need to add 6 to both sides. So I could have simplified, certainly. I get y equals 1. So I have an x, a y, and a z. And those were miserable by hand. This one wasn't bad, but they could be a lot worse. Now, we learned you can solve a system using augmented matrix I talked about. Okay, an augmented matrix means first removing the variables, and then we're going to use row operations to find what's called reduced row echelon form. Remember, I said the calculator is going to take care of this, but we're going to show you how it works, okay? So just keep watching. The augmented matrix for this one we just did, I took out the x, y, z, so we had 1, -2, 1, -1, 2, 1, -3, -7, 3, -1, 2, 0. Okay. Now, there are operations you can do. You are allowed to switch 2 rows around. Think about that. That's just switching 2 equations in the order in which you wrote them. You can multiply 1 row by a non-zero number. In other words, you can multiply all the way through by 7. And then you can add 1 row to another row, which is what I was really doing here. Remember, we multiplied through and then we added things together. So you can do that without the variables in there. All right, just watch. This is entertainment for all of you, I know. All right, so if you change this to a matrix, 1, -2, 1, -1, 2, 1, -3, -7, 3, -1, 2, 0. Then, here's where it gets weird. I'm going to take the first one by -2 and I'm going to add it down to here at the same time. So I'm going to do -2 times 1 added to 2 is 0. I'm leaving the first one all alone. I'm only know how to do this because I was old and had to do this by hand all the time. Negative 2 times 1 is negative 2. Added here is 0. Negative 2 times negative 2 is 4. Added to 1 is 5. Negative 2 times this 1 back here is negative 2. Added to this is negative 5. Negative 2 times negative 1 is 2. Added to this is negative 5. Now, before I write down the third row, I'm also going to multiply the top one up here by negative 3 and add it down here so that I get a 0. Negative 3 times 1 added to 3 is 0. Negative 3 times negative 2 is 6. Added down here is positive 5. Yep. Negative 3 times 1 is negative 3. Added to 2 is negative 1. Negative 3 times negative 1 is 3. Added to 0 is 3. All right. Now, I could do a lot of things next. I'm actually going to divide this row by 5 or multiply it by 1/5. So I'm going to leave the top row the same, but I'm going to write it way over here. And the next row I'm going to multiply by 1/5, so this becomes 1, negative 1, negative 1. Now, I'm also, before I write that last row, I'm going to go ahead and multiply this by a negative 1 and add it down here. So I'd get 0 added to 0 is still 0. Negative 5 added to 5 is 0. Negative 5 times negative 1 is 5. Added to negative 1 is 4. Negative 1 times negative 5 is 5. Added to 3 is 8. Now, we could stop here because this last sentence, if you put it back in XYZ, says 0x plus 0y plus 4z equals 8. So I could stop right there and say z is 2, and then I could plug that back in and find some things. I'm going to go ahead and do a couple more steps here. I'm going to do 2 times this row and add it to the top one up here. So 2 times 0 is 0, added to 1 is 1. 2 times negative 1 is 2, added to this is 0. 2 times negative was negative 2, added to 1 is negative 1. 2 times negative 2 is negative 2, added to 1 is negative 3. This next one I'm going to leave the same. And I'm going to divide by 4 down here. Or multiply by 1/4. All right, then I'm almost done. Last thing I'm going to do is, let's see, I am going to do this bottom one times negative 1 and add it to the top one. So 0 added to 1 is 1, 0 added to 0 is 0, negative, I just need to add it. I don't need to multiply by negative 1. Okay, positive 1. So 1 and negative 1 is 0, and 2 and negative 3 is negative 1. And then I'm going to add this one to this guy. So 0 plus 0 is 0, 0 plus 1 is 1, 1 and negative 1 is 0, 2 and negative 1 is 1, and I'm going to leave the last one. Okay, this form right here that I arrived at is called reduced row echelon form, because if I were to put back in x, y, z on all of those, I'd have 1x plus 0y plus 0z equals negative 1. And then I'd have 0x plus 1y plus 0z equals 1. And the bottom sentence would be 0x plus 0y plus 1z equals 2. So that means I have x is negative 1, y is 1, and z is negative 2. I just solved that system, and I hope to goodness I got the same thing as I did back here. Negative 1, 1, and 2. What did I do wrong? Okay, let's go back to this one. Oh, I have z as 2. Why did I write -2? Right here it said z is 2. Oh, right there, because that looked like a -2 to me. Okay. Z is +2. So they were the same. Okay. Phew. Those are both long and complicated. What if I could enter in this matrix right up here into my calculator, and it would magically change it to reduced row echelon form? I'm going to do that real fast, but then I'm going to do it slower and show you. Okay? But I'm going to do this one without talking through it too much. I'm going to go to Matrix, Edit, and I'm going to make a 3x4 matrix. And I'm going to put in this guy right here. 1, -2, 1, -1. Just kidding. Apparently I'm not going to, because you know how much I love using this online calculator. 1, enter, -2, enter. Oh my gosh, this thing hates me. Okay, and then 1, -1. The next row was here. Maybe if I just slide it over, I can see right here. 2, 1, -3, -7. And then 3, -1, 2, 0. You should always proofread these to make sure that you have them right. I'm going to just hope I do. Then what you're going to do is you're going to go back here. You're going to go over to Math and say, I want to find what's called the reduced row echelon form of, and I put that in matrix A. And it's going to give you this magic, which I typed something wrong. I knew I should never have assumed I had it in right. All right, guys. Oh, it was a -7, darn it. Well, the good news is, besides the fact that my son is home and it's going to just stop the video briefly here, when I go back here, I'm going to hit enter. Boom, there we go. 1, -1, 1, 2. Look how nice that was if I put it in right. All right, I'm going to stop the video and start it again in a second. All right, so we're going to learn to do this magic in our calculator. If you can continue to apply these these properties or operations, you will get to what's called reduced row echelon form. But again, it's on our calculator in one step. So the command on the calculator we're going to look for is RREF, and it stands for reduced row echelon form. So when we have reduced row echelon form, this part of the matrix is going to just be zeros and ones, and then you're going to have answers over here. So this is going to say A equals 1, B equals 1, C equals 1, if you had something like this. All right, so we're going to do reduced row echelon form for this. Now, right away we have to put in a 0 here, and it's actually for the Z. So the matrix we're looking at is 1, -2, 1, 15. This is why we did augmented matrix yesterday, so you could practice this part. -2, -1, 2 equals -1. And then this is an X, so it goes here. This is 1Y, so it goes here. There are no Z's, so we have to put a 0 in here, and -9 over here. So this is what we're going to put in our calculator. And then we're going to ask it to do reduced row echelon form. Okay, so here's the directions all written out. You go to matrix, which is second and then the key below math, which is the -1 here. Second, then that one. And then you're going to go over to edit, which is 3 to the right. You have to tell it what size. And it might have old numbers in there, but you don't care. You're just going to type right over them. Put in the entries, and then you have to quit, which is up here, second mode, and go to the home screen. Then you go back to matrix, second matrix, but this time you only go to math. And then you find RREF, which is faster if you actually go, I believe, up than down, but you'll find RREF, or it's the B. It's actually, oh, then you're going to put the name of the matrix in here. But if you're using the alpha, it's B. And then the name of the matrix, wherever you stored your 3x4 matrix. I usually just use A, matrix A. Okay. So we're going to go back and do this one right here. So we're going to go to the calculator, second, and then this negative, oh, whoa. Doesn't matter what mode you're in. I'm obviously not in function mode, but that's okay. Second matrix, arrow to the right to edit, enter. If you don't have one in yet, you're going to put 3x4 for this particular one, though you can use it for smaller ones, like just a 2x3. And then you're going to put in this matrix. So 1, enter, -2, enter, 1, enter, 15, enter. And then this row is -2, -1, 2, -1. -2, -1, 2, -1, I think is what I said. Okay, then -1, +1, 0, -9. Negative, positive, 0, -9. Okay, then proofread it. Oh, this time I actually did proofread and it looks okay. Then I quit. This is important. You have to quit and go back to the home screen. Then do second and the matrix button again. And this time you want to perform some math. So go over to math and then up arrow to find that magic button that's hidden here, this one called B, RREF, reduced row echelon form, and you want to put the name of the matrix in here. It won't work till you have a name there. So I'm going to go second matrix again. I stored it in matrix A. I could put it in any one I wanted, but I'm just going to hit enter so that I have the name of matrix A. Okay, maybe I'll do B next time just so you can see how that works. But then you just hit enter and it should give you, this means 1x equals 4, 1y equals -5, 1z equals 1. So all that magic, and I didn't have to think hard at all. Let's see, is this on the next page or further down on this one? No, it's further down here. Let me put that picture back down here. And that matrix means that we get 4, -5, and 1 for our 3 variables, x, y, and z, and we didn't have to hurt our brain at all. I want to talk through this because there can also be no solution or many solutions when you have reduced row echelon form, okay? If you were to do reduced row echelon form and you had a whole row of zeros, that would mean that there are infinite solutions because you have a true statement at the end here, 0 equals 0, okay? And you could work with that to write a system like this. You could say z can be any number, y can be -3 minus 2z, x can be 4 plus 6z. In a normal year, we would do and practice that, but this year we're not going to worry about it. So if you want to practice some of those, you certainly can. But so what does this mean? Well, this one solves x equals 19 y equals 4, and z equals negative 20. So you just have 19, 4, negative 20. This one, you have an x minus a z equals 0. The second sentence says y plus 2z equals 0. And the third sentence says 0 equals 1. 0x plus 0y plus 0z equals 1. Well, this is not true, so then you say no solution. When you have at the bottom a sentence that's not true in reduced row echelon form, which will generally be 0, 0, 0 equals 1, you say there's no solution. It means at least two of these are parallel lines, so there's no point where all three lines intersect. This one, though, when you have a row of all zeros, the first sentence says x minus 6z equals 4. The second sentence says y plus 2z equals negative 3. The third sentence says 0 equals 0, which is true. So this would have many solutions because it means at least two of the lines overlap. They're the same line. So you get to just stop there this year, okay? Last year you would have had to say this could be x equals 4 plus 6z, and this one could say y equals negative 3 minus 2z. And so if z were any number, you would have a solution that looked like this. Okay, I'm not going to worry about those this year. Actually, I'm not sure any of that is on, I know it's not on summative. I don't think it's on Delta Math either. But I just wanted to show you those. All right, we're going to do these on the calculator. I will write the matrix first. Negative 2, negative 1, 1, 0. 1, 2, negative 1, negative 3. 3, 1, negative 2, negative 1. Make sure everything lines up. And be careful on some on Delta Math, they're kind of crazy. You have to do some rearranging so that they're in that order. All right, I said I would use matrix B this time. So I'm going to go second to the matrix button down here. I'm going to go over to edit. I'm going to go down to B. You certainly don't have to. You can do it right over the top of A. And it would be a 3 by 4 again. Make sure you have enough spots here to enter what you want. All right, this one goes negative 2, negative 1, 1, 0. The next row was 1, 2, negative 1, negative 3. Okay, I don't know if I remembered that right or not. So far, so good. 3, 1, negative 2, negative 1. What was the last one? Negative 1. Okay, proofread. When I proofread, I usually go down just to look at it differently. Seems right. Okay, then I have to quit second mode, go back into matrix, second matrix, but go to the math. I want to perform some math on one. Find RREF, not just REF. You want the one that says reduced row echelon form, otherwise it won't completely reduce it. Now this time I put it in B, so I'm going to go second matrix and down to choice B. And then hit enter. I just wanted the name on the screen. So this time my solution is 2, negative 1, 3. Make sure you don't have any weird rows in there, but they clearly say x equals 2, y equals negative 1, and z equals 3. All right, we're going to do this one, but we're going to need some zeros. Negative 1, negative 1, negative 1, negative 11. Joy. 1x, 0y, negative 1z's, and 2. This one has 0x, 2y, 4z, and 0. All right. I think I'm going to go back and just use A this time. So I'm going to go back in to second matrix, over to edit. I am going to put it in matrix A again. I have -1, -1, -1, -11. Lovely. -1, -1, -1, -11. Which you actually could enter as 1, 1, 1, 11. Because remember, you can always multiply through by anything. But 1, 0, -1, 2. 1, 0, -1, 2. 0, 2, 4, 0. I'm going to say a prayer that those are in there right, and then I'm going to go quit. Second matrix over to math, up to RREF, and then I'm going to put in the name of matrix A again. Now, eventually when you've done enough of these, I could have simply gone back up to one that said RREF A, and as long as I've changed A, it would have done the same thing, okay? I didn't have to retype it in, but you won't remember how to find the buttons if you don't do it a few times on your own. Oh no, is this one no solution? Look, I have 0, 0, 0, 1. I need to look at my answer key. I wonder if I put something in wrong. I must have. Jiminy. That's what happens when I don't proofread. Seriously, Hawkpower? Edit. It's supposed to be, that one was right. Okay, what have I done wrong? Oh, there was a 4. This first one is a -4. Oh my goodness. I wrote it down wrong on the paper. Ugh. You've probably all been yelling at me the whole time and I can't hear you through the video. Okay, once I fix it, then I can just go back here, go up and hit enter. There we go. 3, -2, 1. Oh, this was a -4. Good grief. Okay. And then I have a word problem. Manufacturing. Tables, chairs, and stools. Last week it built 275 items. Number of chairs built was 4 times the total number of tables and stools. The total value of items was a huge number, with a chair selling for 150, table for 200, stool for 75. Write and solve a system of equations to determine the number of each item built. So we have X equals number of, I'm going to go chairs. Y equals, I'm looking right here, tables, number of tables. Whoops, tables. Can't spell either. And Z equals number of stools. Okay, then we have an equation that says they built a total of 275 items. So we have an X plus a Y plus a Z for the total number of each has to total 275. And then there's a weird one in here. Okay. It says the number of chairs built was 4 times the total number of tables and stools. They built a lot of chairs. So if I distribute and I subtract all this over, there's the equation I get. So that's what I'm going to write. X minus 4y minus 4z equals 0. And then I have this sentence about the cost. Each chair sold for 150. I'm sorry, sales, not cost. And a table for 200. So that's 200 times Y. And stools were 75 times Z. And that's supposed to be $42,125. Okay, we're going to put that in our calculator. second matrix over to edit. It is a 3x4. The first sentence was 1, 1, 1, 1, 275. The second sentence was 1, -4, -4, 0. And the last sentence was 150, 275, and 42, 125. One, 1, -4, -4, 150, 200. Okay, I'm praying I got them right this time. So if I quit, I put them in A, so I should just be able to go back up and grab one of these and hit enter. Otherwise, it's second matrix over to math and then second matrix to get the name. And I got 220, 40, and 15. There are quite a few word problems on your assignment today, I think, on Delta Math. I mean, several, not like a ton, but okay. Did I get that written down right? 220, 40, and 15. Okay, so 220 was chairs, 40 was tables, and 15 was stools. All right. The last thing I want to review, you also have on Delta Math a set of inequalities. So we're going to go through this one quick. Taylor is working 2 summer jobs, making $7 an hour washing cars and $11 an hour landscaping. In a given week, she can work a maximum of 13 hours and must earn no less than 110, so 110 or more. Okay? If X is the number of hours washing cars, so X equals cars, and Y is the number of hours landscaping. So we have a couple equations here. She can work a maximum of 13 hours, so the total of hours has to stay less than or equal to 13. And then it says she needs to earn no less than 110. So at $7 an hour washing cars and $11 an hour landscaping, she needs to earn greater than or equal to $110. Okay. So we're going to graph these inequalities. The first one, X plus Y is less than or equal to 13. I'll do in red. The intercepts would just be 13, 0, and 0, 13, or you could make it this equation, but it should be here, and she needs to stay below that. Okay? The second equation was 7x plus 11y is greater than or equal to 110. So if I subtract this over and divide everything by 11, I get -7/11 x plus 10. So this one would start at 10, and it would go down 7 and over 11. And so this is the line we're talking about, and she has to stay above that line. So the solution set, and my picture is really wonky, but it's points in here. So you need to find a point in here that works, and that's what you will tell Delta Math is any point in shaded area. So 111 works right there. Okay, 112 actually works. 210 works, I believe. Okay. So if you want to double check, you would put them, sorry, I went to the wrong slide. You could put them into these equations and make sure that they are true, like 210 would make this be 12, and if you put a 2 and a 10 in here, it would work. So you could put 2 hours washing cars and 12 hours landscaping. Okay, but I believe you will have to drag the equations and shade on the delta math. Oh, really? All right, this one has 4. You don't have this one, so you get to just watch, but please watch because I think you have to do one of these. Xavier owns a food truck that sells tacos and burritos. I'm going to jump down here. It says X is tacos and Y is number of burritos. So is only enough to make 130 tacos or burritos. So X plus Y is less than or equal to 130. I'm going to graph that real quick. 130 here. It would cross at 130 down here. I'm going to cheat and use my line tool because I want this to look nice. And it said less than, so he needs to be underneath that. Oh, I shouldn't have done those in black. All right. Scroll back up here. Second equation. He sells tacos for $5. And burritos for $8. He must sell no less than, so greater than or equal to, $780 worth of tacos and burritos. So if I solve this for Y, Nitro, stop. Let's see, 780 divided by 8. 99.7. Did I do something wrong? 97.5. I can't read my calculator. Is that what I had on here? Oh, I don't have notes on this. Okay. So 97.5 down 5 and over 8. Let's see if I can find the other intercept. If you put a 0 in for Y, put a 0 in for X, you get out 97.5. But if you put a 0 in for Y, you'd have 780 divided by 5, which is 156. I just want to be able to draw this halfway accurately. So it would go from there to 156. Line tool, and that one it had to be greater than, so we are so far restricted to this little area in here, greater than this green line and below the red line here. But I believe there's more equations. If we go back up here, it says he can sell no more than 40 tacos. So tacos is X, and X has to be less than or equal to 40. That is an X equals line, which means we have a line. I'm actually going to change the line to blue here. That goes here. And it must stay less than that line. So now he's down to this little space in here. One more. It also says that he must, and at most 100 burritos. So he has to stay less than 100 burritos. So that line, if I turn on the line tool and purple, that line is here. He has to stay below that line. So now, if he's below the purple and in between the two black and to the left of the blue, this is the space we're talking about that works. So then we could say anything in that space would work. So nitro. He could have like 2090 is in that space right in there. 2090 would be right here. He could have 3090. He could have 3095. He could 3098. Okay, 3590. All of those would work. Any number in that spot. And then you would just go into Delta Math. And let's see, let's do 3090. And you could say 3090 and check. Now you could check it in all of these equations. Our x is less than 40, our y is less than 100. They add up to 120, which is less than 130. If you put it in here, you would get 150 plus 720, which is greater than 780. So it checks in all 4 equations there. Okay, so I'm sorry this is so long. Good luck. I think you'll like doing these on the calculator. They will not take long at all.